Chapter 10, Section 4A. Learn to identify independent versus dependent events. Essential question: how do I find the probabilities of independent and dependent events? Some vocabulary terms: compound events, independent events, and dependent events. A compound event is made up of two or more separate events. To find the probability of a compound event, you need to know if the events are independent or dependent. Events are independent events if the occurrence of one event does not affect the probability of the other. Events are dependent events if the occurrence of one does affect the probability of the other. Determine if the events are dependent or independent. A. Getting tails on a coin toss and rolling a 6 on a number cube. Think about, do those two things have an impact on each other? No, tossing a coin does not affect rolling a number cube, so the two events are independent. B. Getting 2 red gumballs out of a gumball machine. After getting 1 red gumball out of a gumball machine, the chances for getting the second red gumball have changed, so the two events are dependent. A. Rolling a 6 2 times in a row with the same number cube. The first roll of the number cube does not affect the second roll, so the events are independent. B. A computer randomly generating 2 of the same numbers in a row. The first randomly generated number does not affect the second randomly generated number, so the two events are also independent. Probability of independent events. If A and B are independent events, then the probability of both A and B happening is equal to the probability of A times the probability of B. 2 boxes each contain 4 marbles: red, blue, green, and black. 1 marble is chosen from each box. What is the probability of choosing a blue marble from each box? So from the first box, our probability would be 1 out of 4. From the second box, our probability would be 1 out of 4. These are independent of each other because they are separate boxes. So we take our probability of a blue from box 1, our probability of a blue from box 2, and we multiply them together. 1/4 times 1/4. So our probability of getting 1 blue from each box would be 1/16. 0.0625 is a decimal, or 6.25% as a percent. Let's look at what happens if we're asking for the probability of choosing a blue marble from one box and then a red marble from the other box. The probability of a blue, no matter which box it is 1/4. Probability of a red, no matter which box, is 1/4. So the probability of drawing a blue and a red is 1/4 times 1/4, 1/16, same as the blue, because the probabilities were equal. To calculate the probability of 2 dependent events, do the following. Calculate the probability of the first event. Calculate the probability that the second event would occur if the first event had already occurred. Multiply the probabilities. So we still multiply the probabilities. However, we have to make sure we're taking into account that A has happened and that impacts B. The letters in the word dependent are placed in a box. If 2 letters are chosen at random, what is the probability that they will both be consonants? Prior knowledge, what is a consonant? Consonant would be all the letters that are not vowels, so everything that is not A, E, I, O, U. Because the first letter is not replaced, the sample space is different for the second letter. This means the events are dependent. Find the probability that the first letter chosen is a consonant. So the probability of the first consonant would be D, P, N, D, N, and T. That's 6 out of the 9 letters. If that happened, now there would be 5 consonants and 8 letters left in the box. Doesn't matter which one we took, it just matters how many. So the probability the second letter was a consonant is 5 out of 8. So we went from 6 out of 9 to 5 out of 8, we multiply them together and get a total of 5/12 when reduced. So the probability of choosing 2 letters that are both consonants is 5/12. Let's look at another one. If two letters are chosen at random, what is the probability that they will both be consonants or both be vowels? There are two possibilities, two consonants or two vowels. So we're going to calculate what we want to be the outcome. The probability of two consonants was calculated in the previous example. So now we need to find the probability of getting two vowels. Probability of the first vowel would be 3 out of 9. E, E, E. There are 3 vowels out of 9 letters. So if we chose a vowel, there are now only 2 vowels left and 8 total letters left. So for our second vowel, it's 2 out of 8 or 1/4. We multiply those together and get 1/12. So we're happy with this outcome, or we're happy with the outcome that we had previous of 2 consonants. So we add the 2 events together. When it's an or, we add them together. When it's an and, we multiply. So we would be happy with the outcome 1/2 of the time. One word that's involved with probability is mutually exclusive. Mutually exclusive means the events cannot both happen at the same time. So if I was asking you to roll an even number on the dice, but I at the same time wanted you to roll a 2 or a 3, you couldn't do both. You can't have a 3 and an even number on one dice at the same time because they don't overlap. That's it. Make sure your notes are filled out completely. Go back to anything that you need to review, and you're done.